What exactly did you and your team discover about the Iberian harvester ant, and why is it so extraordinary compared to what we normally know about reproduction in animals?
Yes, so basically what we found is that an ant queen is able to lay two different species. So we normally assume that living organisms can only give birth to same species offsprings. But here, this ants doesn't follow this very common rule. Um, because so this ant is yeah, a very common European ant called Messor ibericus. As they can give birth to males from their own species, which is normal, but so they can clone males from another species, which is called the builder harvester ant, in Latin Messor structor. And so, yes, these two species have very different genomes and morphologies and are separated by more than 5 million years of evolution, which is approximately the same amount of time that separates the human from the chimp.
So as a reader, when I read about your discovery, the first question that came in my mind was, how can one queen produce two completely different kinds of ants, her own species and another, and what makes this process different from a simple hybrid or crossbreeding?
Okay, so from a purely mechanistic point of view at the cellular level, what happens is that normally you have so ova and sperm, and you have an embryo when the sperm fertilizes the ova. And in this case, the genetic material of the ova is removed at some point. We don't exactly know how and when, but for sure the genetic material of the mother is removed. So in the end, you just have the genetic material of the father, and so it ends up with a clone, a perfect clone of the father.
Right, sir. And your research also suggests that Messor ebricus lost the ability to make its own worker ants millions of years ago. So why would a species evolve in such a risky direction? How has it managed to survive since then?
Okay, so it's a little bit complex. So basically, the evolutionary scenario that we imagine for this to happen is is so you have to imagine that first the two species live side by side, okay, in the same geographical area, and um, Mesoamericanus acquired a kind of mutation where they lost the ability to produce worker ants by themselves. Okay, you have to imagine that when the queens mate with the male of their own species, they can only produce new queens, and they can't produce workers at all. And so they absolutely need workers to have a functional colony. And so the solution that they found was to steal the sperm of another species, Mesostructor in this case, in order to produce hybrid workers. This is the only way they have found to produce workers, which kind of makes sense because having hybrid workers may be advantageous because it's like crossing a horse and a donkey to have robust mule. You can imagine that the workers, the hybrid workers, are more robust. And so scientists call this kind of phenomenon sperm parasitism, which is the fact that some queens need to steal sperm from another species to have workers. So this phenomenon is not that rare. It's not very common, but I mean, it's not new. There are several species of ant that do that, and so this is the starting, the first step, okay, of the scenario. After that, when you are at this point, you're queen relying on another species to further your workers, and if when you're in this situation, you're stuck because you can only live where the other species live. A little bit like hunters that rely on the presence of their prey around. Um, and there is a major limitation of this system is that um, so they need to mate with several males at the same time of several species. But if a Messor queen managed to clone the males they need directly in their nest, they cannot outsmart the system, basically, because instead of chasing down some mesostructural males in the wild, they can clone them. They kind of domesticated actually the males of the other species. Okay, because these clonal males now live right inside the nest, uh, like a private sperm bank, if you want, or like livestock that they can keep close at hand for easy access. So this is a huge advantage for them, okay, because they have these males next to them, and because of this kind of genetic hack, they don't need to live near mesostructure colonies at all. They broken free, and today the colonies can independently produce millions of hybrid workers that are spread across southern Europe from Spain to Greece. And all this thanks to this domesticated lineage of clones that's been passed down for generations. So yeah, they basically domesticated these males, and domestication is an advantage.
Certainly, sir. And you have described this new reproductive system called xenoparity. Could you please
Yes.
explain that term for us and why scientists see it as a breakthrough in understanding evolution?
Yes, so Xenoparity comes from the Greek which means foreigner, alien. We know this prefix, the Greek prefix, because it's used for the word xenophobia, for example. Um, and parity is means basically giving birth. We also know this suffix because it's used for oviparity or viviparity, for example. And so xenoparity basically means literally giving birth to alien, to foreign, to a foreigner, to an alien species, basically. Um, and so we define it as the need to clone another species as part of your own life cycle. Okay, so Xenoparus females need to clone males of another species as part of their life cycle for their own survival.
Right, sir. And looking ahead, what are the key mysteries that remain, especially about how the queen can erase her own DNA and clone sperm, as you mentioned? And could this discovery have lessons beyond ants, perhaps even for cloning research in other species?
Yes. Uh, you can imagine actually that we can use this discovery to but when we will understand the precise cellular mechanism, maybe we can inspire ourselves from these ants to make some stuff like cloning a mammoth, so extinct species like a mammoth, with an ova from a surrogate elephant female, for example. You can imagine that it can help us for that, or it can also improve our own cloning techniques.
Thank you, sir. Thank you so much for your valuable time and insights. I'm sure this would give our audience a lot of clarity in terms of this
Yes,
fascinating discovery. Thank you for joining
thank
in.
you.